Right, it's 12 sharp. We can start. Thanks a lot, everyone, for joining this first executive brief, one of four actually, which are specially crafted for you to help you make better decisions with data. I'm Matthias Galipaud. I'm a senior data scientist at SDSC, and today I'll talk about training machines to reach impact with data. And when I mean training machines, I actually mean machine learning, right, which is the backbone of all the AI tools that we know nowadays. Like, you know ChatGPT, of course, but you might also know computer visions like Sora. You might also already use recommender systems, for instance, which are quite widely used in Amazon and other big platforms like this. And first, I'd like to start with a small example. I'm particularly happy that you are able to join at 12, because I must say that this idea of having a meeting at 12 was a bit of a gamble. We actually thought about it a bit. We used kind of a small heuristic, thinking that most people that would join would be executives. They might actually give the work in the morning a bit, like work a bit longer in the morning until 1 maybe, which would give them the opportunity to join the meeting at 12. But doing that, we kind of used, as I said, the heuristic. We actually asked our expert in communication here, Uta, what was the best decision to take. And she told us that, yeah, based on her experience, that would be a good idea actually to have the meeting at 12. That is called an expert rule, right? We ask our expert, Uta, she tells us it's the best strategy to take, and we implement it, right? The problem with expert rules is that they require experts. So we're happy to have Uta, but you might not, in more complex situations, you might not always have an expert in the specific kind of business decision you want to make. The other problem with experts or expert rules is that they don't keep up very well with digitalization. Nowadays, companies are mostly digital, as we know. They have clients and client data from their behavior online. And if you take, for example, Galaxus, right? As soon as a new client comes in, you don't have a specific expert that is able to predict the behavior of that client and propose a new product to that client specifically. Instead, we use past data from that client behavior online to predict what that customer would actually like in the future. And finally, they hardly span over multiple domains, those expert rules, with different sources of data like text, like video, images, like tabular data, right? It's difficult to gather enough experts to make the best decisions out of all these different types of data. So what do we actually need in 2026 to make the best decisions? We need systems that are able to integrate big data effectively. We need systems that summarize information from multiple sources. We need to be adaptable to new changes and opportunities, like new products coming in, for instance, or new types of data coming in. And we need to be able to generalize well to new use case, new customers, new products, right? So what we actually need is machines that are trained specifically on certain data sets to help us make those decisions. So how do we train those machine learning models, right? Let's take again our example from before. Instead of having an expert telling us when to have the meeting, we could actually use data from Swiss workers, right? And some characteristics of those Swiss workers, like what are their Swiss, French, Spanish, and so on, what level they are at their companies, CEO, directors, or whatever, and whether they work until 1, for instance. I just gave a few examples of features there, but in reality, we have a lot more features on and a lot more data on those people. We also collect a specific variable which is called the target, which is what we actually want to know about that person, right? Whether that person eats at 12 or eats later, is able to join a meeting at 12 or later. And using those features and this target, we can then feed that to an algorithm. In that case, it's called a decision tree. And we let the algorithm figure out itself what is the best decision to take, the best path to take in that tree to classify the different people that we have in our data. So, for instance, the algorithm would go through all the different lines of that data set and decide that the best way of separating the two first rows with the third row is based on nationality, right? Is to say, like, let's say that when anytime I see a person from Southern Europe, then I can predict that that person will eat later, right? So that's one way of doing it. And again, this is something that the algorithm does automatically, right, or by itself. So now we have a trained algorithm, but we need to keep in mind that we like as is, it's a bit useless actually. Like the real goal of training that algorithm is to use it in real world context. Right? We want to know how to best recommend items to new clients. We want to know what is the best word to predict after a certain sentence. That's the basis, for instance, of ChatGPT, right? So we need to test the ability of that algorithm to perform well on real world settings. But it's difficult to access the real world, right? Instead, we use a small trick, which is to separate our collected data set into training data and testing data, with the idea that this testing data, which will not be seen by the algorithm, will be used actually as a simulation of the real world, right? Something that the algorithm hasn't seen before. And with that, testing the model on testing data, unseen data, we were able to check whether the model generalizes well, whether the chatbot that we implemented in our company actually is able to answer customer questions that it hasn't seen before, whether new products coming in on Galaxus are well recommended to new customers that are coming in, and whether we're able to forecast the market well, forecast the future well, for instance, and all of the use case you can actually think about. What I showed you in those few minutes is actually the backbone of what machine learning is nowadays, or AI tools are nowadays. This is how we train large language models. This is how we train more classical machine learning, time series models, and so on and so forth. And this is what actually empowered you to create new products using AI, to automate processes in your companies, to train recommender systems, and whatever you can think about, basically. So if you're interested in exploring more of those topics, I urge you to join our 5 days deep dive course on the topic. Right, this will happen from the 23rd of January 2026. You don't need to have any prior experience in coding. You don't need to know much about data science beforehand. The only thing that we want is your enthusiasm and your ideas, your business ideas that you would like to implement using AI. What can I tell you? Like the day will span over the course will span over 5 days, not necessarily consecutive, but it will encompass a large array of different topics in AI. To give you an example, day 3 we'll talk about unsupervised learning, so time series, for instance, and more responsible AI. I'm personally responsible for the explainability course about responsible AI, which talks about how to explain the predictions of AI models, right? We all know that there are black boxes, but sometimes it's really important to know how they actually come up with a specific prediction to trust those machines better. So please join. There's actually an end of the year discount. So it's a 10% discount. You can actually secure your seat by looking at this QR code. Let give you some time to actually have a look there. The course, as I said, will start January 23rd. And then we'll span over 2 days, 29th and 30th, and then we'll finish February 6th, 2026. It will take place in Andreasturm, so the Swiss Air Tower, which is right next to Oerlikon station. So please join.